At the heart of every game is the game loop. This is essential to how your game runs. This is like at the very core. And basically, as a general rule, you do three things in your game loop. You poll input, so keyboard events, mouse events, whatever, you gather all that input from the user. Then update the game logic, so you move entities around within your game world. And finally, you render everything to the screen. And this loop is fundamental to your game. And in the case of Abacus, it was fundamentally flawed. The reason being, as part of my input polling mechanism, I used a call from this framework that I'm using to basically get all the events that have transpired. However, this particular function call blocks while the window is being dragged. And what that means is it just halts your whole program. Everything grinds to a halt when the window is being dragged. And this was causing all sorts of problems. So for example, the connection to the server would time out because it's not able to send messages to the server. So the server just thinks, oh, this player's disconnected. And another problem was that sometimes the physics would just go crazy because when you finally stop dragging the window around the screen, the game thinks you've had a massive lag spike, and it tries to accommodate for that, and it tries to run everything really fast, and it just strange things start to happen. So I did a bit of research about this issue, and basically it's a limitation of the operating system. So there's no easy solution. The recommended solution is to basically separate your logic from your input and rendering, so that even if your input is blocking, your logic is running in the background in its own thread. So it's got its own context in which it can continually execute at a consistent frame rate, so that even when you're dragging the window and your input is being blocked, the logic is still running in the background. And I was super nervous about this change because it involved a lot of reworking of the code, because this is something that's so ingrained in the bowels of the program. And that's partly my own fault for not having a clean enough separation between my rendering code and my logic. There's a common pattern in development called the model view controller, where you try and keep your model, which is basically all your logic, completely separate from your view, which is the rendering, and your controller, which is the input. And if they're nicely separated, it becomes very easy to move things around, or for example, if you wanted to switch out to a different rendering library, you can do that. It's all in one place. You don't have to go digging into the code and kind of pulling out bits and pieces all over the place. And the problem is, because I'm using this lightweight Java gaming library, which is basically a wrapper around OpenGL, there are a lot of functions which you wouldn't necessarily associate with rendering. For example, there's a lot of setup work you need to do before you can render. You need to allocate data on the GPU, the graphics card. Anytime the level changes, if you're in the editor, you change the level. You then need to send the updated level data to the GPU so that the latest level can be rendered. And although that doesn't necessarily seem like a rendering operation because you're just doing setup in response to the level being changed, you're just basically changing the data. But because you're interacting with the GPU, for all intents and purposes, that counts as a rendering operation. In other words, that has to happen on your main thread, which is the thread where your OpenGL context exists. So basically, any rendering operations have to take place on that thread. So for me, for Abacus, this meant pulling out a lot of code that was sort of intertwined with the logic and making sure that that code can only happen from the main thread. Meanwhile, the logic is running in a separate thread. So this was not trivial, and I was very nervous about touching it. I wasn't sure how well this would work, but I'm pleased to say everything is now working. The logic is running in a separate thread, so I can drag the window around the screen, and you'll notice when I release the window, the game just resumes, and it's clearly, you can tell that the players carried on moving even while the window is being dragged, although you don't see the screen update during that time. When you release the window, it's clear that what's happened is the player has carried on moving in the background. So no more server timeouts, no more weird janky physics, and as a bonus, the code is a lot cleaner now. There's a better separation between the model view and controller, so it's a lot easier to maintain. And as an added bonus as well, I've got much more fine-grained control over the game logic thread now. So previously, the rate at which the logic was executed was tied to the rendering, because everything was happening in lockstep. Whereas now, because they're running in separate threads, they can kind of happen at a different rate if needs be. So it just means I have a lot more control over exactly how the logic is run. That's no longer tied to the monitor frame rate, for example. And if I wanted to, I could speed up or slow down the logic very easily without kind of breaking everything horribly. So, thanks for watching. I hope that made sense. It wasn't too technical, or if you're a technical person, I hope that wasn't too much of an oversimplification. If you did watch this video, I'd love to hear your comments below. Maybe give me a suggestion of something you'd love to see in the game. Thanks for watching, and see you next time.